Okay, welcome back. I'm going to be doing intermediate algebra from Martin Gay, 4th edition, and we're going to be doing section 4.4. We're going to do the even numbers up to number 18. This section is on solving linear equations using matrices. And it's very interesting. Let's start on number 2. The equation we have is 2x minus y equals 8, and x plus 3y equals 11. Now, we've already done these on previous sections, and we did them by solving first for one variable, then plugging that one variable after we solved it back into another equation to solve that one. The way that we solve for one variable is by elimination. So, for example, in this problem, we could immediately see that we might want to try to eliminate the variable x from the first equation. What we could do is we could multiply the second equation by 2, subtract it from the first equation. That would get rid of the 2x. That would allow us to solve for y. Having y, we could then plug the y into this equation. So solving an equation by matrices, as we're going to do today, is actually exactly the same technique, only it's a technique in which we formalize it and we don't write down a lot of the redundant items. So in this case, this formula, this set of equations is going to be represented by this matrix, which is just a listing of the numbers that appear in the equation and nothing more. And then what we're going to do is we're going to perform operations on the matrix. And the valid operations on the matrix are we can multiply one row of the matrix by any number we want. That's exactly the same in an equation here as saying that we're going to multiply both sides of an equation by the same number. Or we can add 2 equations or subtract 2 equations. We can multiply any equation by any number and add that to any other row in the equation, and that still, or any other row in the matrix, and that's going to produce an equivalent matrix. It's not exactly the same matrix, but it's still a matrix that represents this solution. And the objective on this is to do this with the intention of making the matrix upper triangular in form. Okay? In other words, the idea is to do exactly the same, and here the book is using A, B, and C for this, is to do these operations in exactly the same manner as we previously did in order to get one equation that would read y equals c. This would represent y equals c. Then we could plug that back into this one and use that one to solve for x, because x is going to be b. If, for example, we got the equation into this form, we could use that to go back and plug into the first equation to get x plus a times c equals b, or x is equal to b minus a times c. Okay. Anyway, there's really nothing new here. What's new is the way that this is done in a more abstract. It's an abstraction. This is the way that, this is similar, very similar to the way that this would be done inside of a computer. The computer doesn't care whether this is an X or a Y, but you're just dealing strictly with the numbers. Okay, so let's get started. We want to turn this into upper triangular. That is, we want to get the first one to be a 1. Now, I should have mentioned something else that we can do. we can swap two rows in the equation very easily. We're allowed to do that, swapping rows. So to make this upper triangular, as a first step, let's just swap the two rows. 1, 3, 11. All that means is taking the two equations and putting one on top of the other one. That's not doing anything, as we would say. Okay, now we're just playing with numbers. We just have to remember what the rules are, what we're allowed to do. Swapping rows, that was something that we were allowed to do. So now that I've done that, let me see, I'm only going to allow myself a certain number of steps before I run out of space, but that's okay. I don't think I need very many more steps. Now the next step is, I'm going to take the first equation, multiply it by 2, and subtract it from the next equation. The idea is to get rid of that 2. Okay, so my first equation, this one doesn't last very long. My first equation, let's see if this works. It's going to stay the same on my next step. 1, 3, 11. The second equation is going to, this first one is going to get to be 0 because I'm going to take 2 and minus 2. Now on this one, I'm going to double this to make 6. And I'm going to subtract a negative 1. Okay, that's going to make 7. 6 minus a negative 1. And this is going to be 22 minus 8. 22 minus 8, that looks like 14. Okay. Now the next step is I have to turn this one into a 1 by only doing the so-called valid operations. In this case, I'm going to multiply the second row by a half. And that's going to 0, 1, and 2. Now the idea is, all of these manipulations are now equivalent to if I had simply done those exact same operations on this two set of equations. I would ended up now with a set of equations that said x plus 3y equals 11. Of course, that's exactly the same as this equation. And I have this other equation which says y equals 2. Okay, that's exactly what this says. Now that means in my final solution that y certainly is equal to 2. And x is equal to 11 minus 3 times 2, or 5. So that's the solution to this. And we could have done it the old way, but now when you get more into the habit of doing it the matrix way, you'll see that you will be able to do them possibly somewhat quicker. And this is just an introduction into abstraction, or introducing the concept of a matrix, which is a collection of coefficients of equations. In this case, 4x minus y equals 5. 3x minus 3y is equal to 6. Okay. Okay, so now let's make our matrix. And let's see, I can't get a 1 in the first position, so I'll just copy it exactly the way that the matrix is. I can't make any initial simplification. Okay, now I need to get a 1 in the top position, right? And yeah, give us the easiest method. Let's see, the 3 things that we're allowed to do. Add any two rows may be interchanged, but that won't do it. The elements of any row may be multiplied or divided by the same non-zero number. Oh yeah, I see one now. These all have a common factor of 3, so if I divide the second one by 3, that's going to give me the one that I want, which I can then move into the top. So I'll do that in 2 steps. 4, negative 1, and 5. It's going to take the second one and divide it by 3. to produce this set of equations. Then I'm going to swap top row and the next row. Okay, and that gives me the one in the first position. And now to get the next one in the next position, I could just divide this second. To get a zero, I'm sorry, not a 1, a 0 in this position. I'm going to multiply the first equation by 4 and then subtract the second equation from it. Okay, that's really the same step that I did last time. So the first one is going to stay exactly the same. I'm going to multiply by 4 and subtract off that one. So that's 4 minus 4. On the second element, it's going to be negative 4 minus negative 1. That's going to be 5. Okay, and then this one I'm going to multiply by 4, and that's going to be 8 minus 5 to give 3. Okay, then the very next step, near the bottom, but on the next step, do I have room for it? Probably not. Maybe just barely. It's going to be 1, 0. I'm going to divide the second equation by 5 to get 3/5. Hi, Karen.
Hi.
How are you? Would you like to learn how to do matrices? I'm doing math. Math problems. Do you have to go to the bathroom? Okay. Now, I have succeeded in doing upper triangular. So now, these equations represent one equation which says x minus y equals 2. The second equation represents y equals to 3/5. Now, we did end up with a fraction, but you can't always avoid a fraction somewhere because that might be the actual answer. What I want to do is just make sure that I didn't accidentally make a mistake on doing this. I think it's okay. Let's just see. That was multiplied by 2. I moved up in the top, moved that one down. Then I took this one, multiplied by 4, negative 4. Oh. No, this equation is wrong. So I see I made a mistake here. Let me go back. It was right here. I multiplied the top equation by 4 and then subtracted the second. Well, if I multiply this by 4, that's going to give me negative 4 minus a negative 1. Okay, that's negative 4 plus 1, which is negative 3. So let's go right back to here. And the reason I detected that, when I double checked the answer at the end, I would have seen that it was wrong, but this negative 4 minus negative 1. That's negative 4 plus 1, which is negative 3. Okay. Now, 8 times 8 minus 5 is still 3. Okay, so the second equation is now going to be easier. And it's kind of a giveaway that I got a fraction there. It doesn't divide the second equation by 3, not by negative 3, to produce a 1 and a negative 1. This now represents the equations. No, not the matrix. The equation. This will now represent the equation. X minus y equals to 2 and y equals to negative 1. So the answer is going to be y is equal to negative 1 and x is going to equal to 1 plus 2 or equal to 3. So we're going to double check that. If we plug in as a first equation, for example, 4 times 3 is 12. Whoa. Oh. Okay. I got the wrong answer. Must have made a mistake. Put a stop on this one. Okay, let me, I had to stop the video for a second there, but I'm starting it up again. And I had just noticed that I was plugging it back in. It didn't work out. So I went back. erased my final step and I double checked here. I have y equals -1. That we have, and then the next, when in our simplified equations, we're also going to have x is equal to y plus 2, which is -1, plus 2, which is equal to 1. So x equals to 1 is the x value. So we have y equals -1, x equals 1. So let's check that into these equations to double check. So this would be 4 minus a -1, or 4 plus 1 equals 5. And that's a sign that we have the right answer. But let's just double check also on the second equation. That's going to be 3 minus 3 times -1, or 3 plus 3 equals 6. So that's a check, and that is correct on that one. Okay. So made a couple mistakes on that one, but found the mistakes when I was plugging them in. Now, let's go to the next one. Minus x plus 3y is equal to 6. 3x minus 9y is equal to 9. Okay, turn it into the matrix. -1, 3, 6, 3, -9, and 9. Okay. Now, to get a 1 in the upper, looks like an easy way is going to be to multiply the top one by -1. Okay, so that's 1, -3, 6, 3, -9, 9. Now to get a 0 in the next column, we'll multiply the top one by 3 and subtract the second. So that's going to be, top equation will be identical. This will be a 0. I'm going to multiply this by 3. That's -9 minus -9. That's a 0. Oh, that's a dead giveaway that we have a problem with these equations. But let's just continue on this one. If we multiply the 16 by 3, we're going to get 18. 18 minus 9 is 9. Now, this bottom equation reads 0 equals 9. Now, one thing that we're going to notice is that, yes, these two equations are inconsistent. No solution. And the way that we notice that is we look back up into the original equations, we'll see that the second equation, for example, if we simply divided it by -3, see the first equation, if we divide the second equation by -3, we would have gotten -x plus 3y is equal to -3. So we have one equation says -x plus 3y is -3. The other one says -3x plus 3y is equal to 6. So these represent, from our previous exercises, these represent parallel lines. They're two lines that have the same slope, but they have different y-intercepts. So they don't have a solution. So the answer on this problem is there is no solution to this. Whether you solve it by matrices or you solved it using the way that we did before, what you might call manually, adding and subtraction, or elimination of variables, you still come to the same conclusion. There is no solution to this equation. No solution. Okay? We're going to call it the empty set. Okay, let's go to the next one. 9x minus 3y is equal to 6. -18x plus 6y is equal to -12. Okay, matrix 9, -3 and 6, -18, 6, and -12. Okay. Well, let's see. I don't see any immediate way? Well, there's a lot of common factors going on. These equations are a little bit overly complicated. Let's divide by 3 just to get things. And the first one's by 3 and the next one by 6, okay? Just as a starter. This is going to be 3, it's going to be -1, this is going to be 2. Divide this second one by 6, and we're going to get -3, 1, and -2, okay? That makes it a little bit simpler. Now, let's add the two. Let's add the second to the first, and that's going to be our new first equation. No, that's not what we want to do. Because we want to get a 1. In our first step objective was to get a 1 in the upper position. So I take that back. Don't want to do that. Could get it's easy to get a 0 in that position. Well, Well, let me do this. I don't always have to do it exactly the same way. I'm going to add the first one to the second one, but I'll leave that in the second position. Okay? So the first one I'm going to leave the same. 3, -1, and 2. Now the second equation, I'm going to add the first one to it just to eliminate this one. That's going to be a 0. Oh, this is a 0. I just got the same problem. Woo, boy. The first equation is just a negative of that. Okay. Well, this is the case where these represent 2 lines that are exactly the same line. One equation is just a negative of the other equation. Okay, so remember now, we can multiply an equation by -1. So if we multiply the second equation by -1, for example, just get the first equation. So this has an infinite number of solutions. Okay, infinite number of solutions. Represents the case where the 2 lines up there are exactly the same. Okay, anyway, that's number 8. Okay, it took me a while to recognize that. So it's kind of a trick question because they ask you for a solution of something. There it doesn't have a solution. Now, the next one is going to be 5x equals 5, 2x plus y is equal to 4, and 3x plus y minus 5z equals -15. Okay, this is now 3 by 3 set of equations. We know right off the bat that this is going to be relatively easy to solve because we can solve the first equation for x, plug that into x in the second equation, solve that for y, plug the x and the y, plug them into the third equation, solve for z. But let's just put this into the matrix form to see exactly how that's going to turn out in matrix land. In matrix land, this is 0, 0, 5, 2, 1, 0, and 4, 3, 1, -5, -15. Okay? Now remember, in matrix land, we've been turning things into upper triangular, okay, with 1s on the diagonal. So I would say as a first step, let's divide by the common factors, okay? On the first equation, for example, there's a common factor of 1. I would say let's get rid of that. And I'm going to simplify by not writing it all over again, and I'm just going to use my hand to erase. Okay, that makes things a little bit simpler. Okay, now, that's the only common factor. So anyway, I got rid of it. But this is almost exactly a lower, this is a lower triangular matrix. So the first thing we want to do is just reorder them to put the bottom on top, because that's going to essentially make it triangular in the way that we want it to be. We'll leave the same second one. Okay. This is now lower triangular. I'm sorry, upper triangular. That was the form that we have been using to solve these equations. We've been putting them into. well, it says use matrices to solve the equation, but this is triangular, and this is an upper triangular, but it's triangular in this direction, not in this direction. The way that we had been doing them is we've been trying to make them triangular in that direction. Okay. There are a couple of things we can do here. Even before reordering, we could just ignore that. And noticing that the matrix is triangular, well, they didn't tell us about this, as far as I can tell. Yeah. But we could solve this straight off using exactly the procedure that I mentioned. This is already solved as far as we're concerned, except to say that we would want to get a 1 in this position, according to the way that they had described the, in other words, right off the bat, we see that x is equal to 1, right? In other words, we could take this and immediately plug it in and say that x is equal to 1. Then in the second equation, that simply says 2, or y, is equal to 4 minus 2, which is equal to 2. And that negative 5z is equal to negative 15 minus y, which is minus 2, minus 3x, which is minus 3, or negative 5z is equal to, that's negative 20, or z is equal to 4. So x is equal to 1, y is equal to 2, and z is equal to 4. Yeah, what is it?
Wow, you're good.
We're doing math.
You're good at that. You're really smart, Becca.
Thank you. Thank you. Yeah, well, we're solving these equations. Now, what I was supposed to do is multiply the third row by negative 5. So this would be negative 3/5. This would be negative 1/5. This would be a 1, and this would be a 3. Okay? And that would have this into this triangular form. Now, it wasn't exactly, it's not exactly the triangular form that they were asking about. For them...
Oh, you just figure it out by the book. You don't use your brain, you use the book.
Well, I have to use the book because that's the way they're asking us the problems is in the book. Now, in this one, if it's reordering the columns is what would put this into an upper triangular form. But as far as I'm concerned, this lower triangular form is perfectly fine. So we're just going to leave this one like that and say that we've solved it. I'm going to move on to number 12. Okay, 12 is the last set of equations here, and the equation is going to be 4y plus 3z is equal to negative 2, and then the second equation is 5x minus 4y equal to 1. The third equation is negative 5x plus 4y plus z is equal to negative 3. Okay? So in terms of matrices, when we look at the coefficients, it's going to be a 0, a 4, a 3, a negative 2 on the first equation. For the second equation, it's 5, negative 4, 0, and 1. On the third equation, it's negative 5, 4, 1, and negative 3. Okay? Now,
Okay, do you see intervals in the process?
let's see now.
Excuse me, do you see intervals in the process?
Okay, let's take a break. And then we'll pick this up in a minute.
Do you see ocean animals?
Okay, let's try to pick up where we left off on this problem. This was the last problem. And one thing to remember on these types of problems is you have to go through a series of steps to get to your solution, but it doesn't matter if you do each step in a particular way as long as you finally get to the end. So you can play with it. Okay, I'm going to add the second equation to the third equation because I noticed that that's going to cancel out, that these numbers are going to cancel out. And I'm going to explore to see what I'm going to end up with there. Now, so what I'm going to do is I'm going to keep the other equations the same, that is the first two, but I'm going to add the second row. Okay, come look. Look what's going to happen when I add the second row of numbers to the third row of numbers. This numbers 5 and negative 5 gives 0. 4 and negative 4 gives 0. 0 and 1 gives a 1. And then 1 and negative 3 gives a negative 2. Okay? Now this is getting much closer. Let's come sit next to me and I'll show you.
Guess what? I could see it on the camera.
That's right. This is getting much closer to the diagonal form. So now, what I'm going to do is swap the first and the second equation so that the top equation, and that's going to give me something that is diagonal. It's going to be 5, negative 4, 0 and 1, 0, 4, 3, and negative 2, 0, 0, 1, and negative 2. Okay, don't block it now, because people want to be able to see the equations. Okay, now look. Look at that. That is diagonal. So if I solve the second equation by 4 and the first equation by 5, that's going to give me exactly the diagonal form that I want.
9.
So for example, we're going to divide the second equation by 4. That's going to be a 1,
Or 9.
3/4, negative 1/2. Top equation I divide by 5. That gives me 1, 5/4, negative 5/4, and 1/5. Now that is diagonal in a form that should give us the solution. That gives us the answer. Z is equal to negative 2. And we solve the second equation to give us y is equal to negative 1/2 minus 3/4. I'm sorry, it's negative 1/2 minus 3/4 minus negative 2, which is equal to negative 1/2 plus 3/2. That's equal to 1. Good. Okay, and then z, I'm sorry, and then x, which is going to be the one on the top, x is equal to 1/5 plus 4/5 times the y. Y is equal to 1. So that's actually also equal to 1. So let's plug them in. 4y, that's 4 plus 3z, z is negative 2. So we got 4 minus 6 is negative 2. That's correct. Then we've got, let's just double check the second equation. That's going to be 5 minus 4 equals 1. That's correct. Then the last one says negative 5 plus 4, that's negative 1, plus negative 2 equals negative 3. So actually, these are correct. I could have made a mistake here because I was being distracted while we're doing it. But it turns out that we actually did this one okay, and we got the right answer. Okay, this is a little bit, you have to practice these quite a bit and have confidence. And double check your answer at the end.